My dear friends, today we will see how to find the Fourier series of discontinuous functions. Find the Fourier series, find the Fourier series, find the Fourier series for the function f of x equal to x in interval 0 to pi 2 pi minus x in pi to 2 pi. So go with the solution. So write down the given function again. So given f of x equal to x and 2 pi minus x in the interval x lies between 0 and 2 pi, 0 and pi, 2 pi minus x lies between pi and 2 pi. So now let us find out the period of the given function. Observe the periods here. So limit we have 0 to 2 pi. So we can say that the given function is a period of 2 pi. You know that how to find out that period 2 pi. So 2 pi minus 0 gives 2 pi. Therefore, it is of period is of period 2 pi. Next, following the procedure to find the Fourier series, first we can go with finding the function whether it is even or odd. It will be easy to solve the problem. So we have studied a property in second PU called how to find the even function or odd function of period 2 pi or 2a, in general 2a. So if you consider f of x is defined as phi of x in the interval 0 to pi and psi of x in the interval pi to 2 pi. So then change x to 2 pi minus x. If you get back phi of 2 pi minus x is equal to psi of x, then we say that is even function. F of x is even. If you get back with phi after changing phi of 2 pi minus x equal to minus psi of x is odd function. So odd function. So likewise, I can say that x is defined as phi of x and 2 pi minus x can be defined as psi of x. Okay. Now consider phi of x. Here phi of x is equal to x. So change x to 2 pi minus x here. So we get phi of 2 pi minus x, which is equal to x will be changed to 2 pi minus x. So it is 2 pi minus x. So I have defined the function f of x as phi of x and psi of x. So therefore phi of x and psi of x. So we are getting back phi of 2 pi minus x as psi of x. Therefore we can say that f of x is even function. Since the given function is even, we can say that bn equal to 0. You can say that bn equal to 0. Now therefore the Fourier series therefore the Fourier series for the given function is f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx. Since it is period 2 pi, we define that as cos nx. And as bn is 0, no need to write a bn function, so we'll name this as equation star. Now we shall find out the values of a naught and an. As it is even function, a naught is defined as 2 by pi integral 0 to pi f of x dx, f of x dx. So which is equal to 2 by pi integral 0 to pi f of x. In the interval 0 to pi, f of x is defined as x. In the interval 0 to 2 pi, 0 to pi, f of x is defined as x dx. So now integrating this 2 by pi integration of x, we know that integration of x is x square by 2. What is integration of x? X square by 2, and the limits is 0 to pi. So as we have a constant term outside 2 and inside we have 2, as these two are product, we can cancel. 2 by 2 get cancelled. So you are left out with 1 by pi x square, limit x equal to 0 to pi. Now substitute the limits. So which is nothing but upper limit x equal to pi. When I give x equal to pi, it becomes pi square, minus lower limit x equal to 0. 0 square is 0. So you are left out with what? Pi square minus 0 is pi square divided by pi. So 1 pi get cancelled. So therefore a naught is equal to pi. But in the required star, we have a naught by 2. So therefore a naught by 2 is equal to pi by 2. Pi by 2. Now we shall find out the value of an. Now we shall go for finding the value of an now. So an is defined as 2 by pi integral 0 to pi f of x cos n x dx. So 2 by pi in the interval 0 to pi, f of x is defined as what? You can see again, f of x is defined as x. In the limit 0 to pi, f of x is defined as x. So I will substitute the value of f of x as x cos n x dx. Now to integrate this, we shall apply Bernoulli's rule. As you are all aware of Bernoulli's rule, integral of u v dx can be written as u into integral of v dx minus derivative of u into double integral of v dx continuing like this plus minus etc. until the value of the derivative is 0. So to find out the u and v, we shall apply highlight there. So trigonometric term carries v second term, and algebraic term will be a first term u. So applying that rule, 2 by pi now applying the Bernoulli's rule, u is x, integral of cos nx. Integral of cos nx is what? Integral of cos nx is sine nx divided by n. Integral of sin nx is sin nx divided by n minus derivative of x is what? 1. Differentiation of x is 1. Differentiation of x is 1 into double integral of v, as I have defined in Bernoulli's rule, double integral. Integrating again sine term here. So integral of sine is minus cos nx divided by n into n becomes n square. So next differentiation of 1 is 0. So therefore we can stop the integration there. So then substitute the limit. The limit is x equal to 0 to pi. So as we have here sine term here, when I substitute the limit for the first term, uh, if I apply the upper limit, sine n pi, so sine n pi is what? You should know sine n pi is what? You should know the value of sine n pi. What is sine n pi? So remember properly what is sine n pi. What will be the value of sine n pi? Did you got? What is the value of sine n pi? Is 0. Sine n pi value is what? 0. Next, if I substitute the value of 0, when I give x equal to 0, x itself is 0, 0 into anything is also 0, and also sine 0 is also 0. We can say that sine 0 is also 0. So this whole term get vanishes. So now you are left out with minus into minus, minus into minus, plus, and a constant term n square can be taken outside. So it is 2 by pi n square. You are left out with cos n x limit x equal to 0 to pi. Now substitute the limits. 2 by pi n square upper limit cos n pi minus cos 0, so which is equal to 2 by pi n square, 2 by pi n square upper, when I what is the value of cos n pi? Cos n pi is given by minus 1 power n minus cos 0 is given by 1. So this is what a n. Once we came to know what is the value of a n and a naught, so therefore the equation star becomes f of x equal to, can you can see the value of a naught by 2, a naught by 2 values pi by 2, a naught by 2 values pi by 2, pi by 2 plus summation n equal to 1 to infinity n values 2 by pi n square into minus 1 power n minus 1 into cos n x into cos n x. This is the required Fourier series for the given function f of x. So as you observe, the given problem was period 0 to 2 pi. The same problem can be given similarly. The problem can be given as f of x equal to pi x pi into 2 minus x in the interval pi x is defined as 0 less than x less than 1, and in pi times of 2 minus x is defined as in 1 less than x less than 2. So now this is an arbitrary constant period 0 to 2l. It is 0 to 2l, 0 to 2l period. So we can say that now we can say apply same property to verify even or odd function. So change 2 minus x, change x to 2 minus x and solve the problem. You know what is Fourier series, bn will be 0. You know how to write the Fourier series for that. If Fourier series for that function is f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by l, n pi x by l. Here 2l equal to what? 2. You can say that 0 to l, l to 2l. So l is 1 here. L can be defined directly. L is 1. L value is what? 1. So a naught by 2 plus summation n equal to 1 to infinity an cos n pi x. So now you can find out a naught value and an value as we have studied earlier. Okay, we'll solve some more problems on this property called discontinuous functions. Now let us see the problem which is neither even nor odd function. We can see neither even nor odd function. Consider the problem f of x equal to minus pi x in minus pi less than x less than 0 and x lies between 0 less than x less than pi. Okay, as this question was asked in the year June 2018, so there is a chance of asking again. Okay, so why I told you that earlier that it is neither even nor odd means as the given interval is minus pi to pi and the given function is minus pi and x here. So we can say that we can if we apply the property changing x to minus x also will not get back with phi of x or minus psi of x. So that's why it is neither even nor odd function. So directly we should go for finding the period. We shall check for period. If you go with solution, write down the given function. Once again, given f of x is equal to minus pi and x in minus pi x less than 0 in 0 less than x less than pi. So if you apply the property as I have explained, pi minus of minus pi, which is equal to pi plus pi equal to 2 pi. It is a period. It is a period of 2 pi. It is a period of 2 pi. So what is the Fourier series for such type of period? F of x is defined as what? F of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin n x. Name this as equation star. Now we shall find out a naught, an and bn. We require to find out all the three constants a naught, an, bn. So what is a naught? What is the formula for a naught? As it is a period 2 pi, it is neither even nor odd. We know the structure of writing neither even nor odd. It is 1 by pi integral minus pi to pi f of x dx, f of x dx. So as it is discontinuous function, the integral will be splitted as two parts. So that is 1 by pi times of minus pi integral minus pi to 0 f of x dx plus 0 to pi f of x dx. So this is a way of splitting the function. As in the given problem, the function is splitted like this: minus pi, 0, pi. Okay, so in the interval minus pi to 0, we can see once minus pi to 0, the interval, in that interval the function is defined as minus pi. In the interval 0 to pi, the function is defined as x. Here minus pi, in this function, in this interval, the function is defined as x. Just substitute over there. So which is equal to 1 by pi integral minus pi to 0 f of x is defined as, in the interval minus pi to 0, f of x is defined as minus pi dx plus integral 0 to pi. In that interval, f of x is defined as x dx. Now just integrate that 1 by pi. As it is minus pi is a constant term, integral of any constant k, integral of k is with respect to x will be kx. So it is minus pi x, limit x equal to minus pi to 0, plus similarly the integral of x is x square by 2, x equal to 0 to pi, x equal to 0 to pi. Now substitute the limits. 1 by pi minus pi is constant, upper limit x is equal to 0, minus of minus lower limit minus pi, minus of minus pi, plus 1 by 2 can be taken outside, apply the upper limit x equal to pi, so it is pi square, minus lower limit x equal to 0, 0 square is 0, 0 square is 0. Now if we simplify this, 1 by pi times of minus into minus, it is plus pi, plus pi into minus, minus pi square, pi into minus pi is minus pi square, plus here pi square minus 0 is pi square, divided by 2 is there, so it is pi square by 2, pi square by 2. Now simplifying this, so it is of the type 1 by 2 minus 1, 1 by 2 minus 1, or minus 1 plus 1 by 2, which is nothing but minus 1 by 2. So you're left out with 1 by pi times of minus pi square by 2. So cancel one term of pi, you're left out with minus pi by 2. This is what just a naught. What I required in the star a naught by 2. So divide on both this side by 2, we get minus pi by, as I am dividing by 2 on both the side by 2, so it is 2 into 2, 4. to 4. This is what a naught by 2. This is the way of finding a naught. Now let us find out an. We shall go for finding an. 1 by pi times of, how to write an? 1 by pi integral minus pi to pi f of x cos nx dx, cos nx dx. Now as I told you that split the interval, so minus pi to 0 f of x cos nx dx plus 0 to pi f of x cos nx dx. Now substitute the values of f of x in that respective interval. So in the interval minus pi to 0, f of x is defined as minus pi cos nx dx plus in the interval 0 to pi, f of x is defined as x cos nx dx. So in the first term, we no need to apply Bernoulli's rule, but in the case of second term, we have function of x into function of x, so we should apply Bernoulli's rule as I explained earlier. So we can consider the algebraic term as u, and we can consider the trigonometric term as second part b. So in the first term of integration, so we have minus pi as constant. Integral of cos nx is sin nx divided by n, as x runs from minus pi to 0, plus now apply Bernoulli's rule, x into integral of cos is sin nx divided by n minus derivative of x is 1, integral of sin is minus cos nx divided by n into n, it becomes n square. Next differentiation of 1 is 0, so we can stop at this stage. So x runs from 0 to pi. So as I've explained in the previous problem, when I substitute x equal to 0 in the first term, sin 0 is 0, and if I apply lower limit x equal to minus pi, sin of minus theta is minus sin theta, so sin of minus n pi becomes minus sin n pi. Sin n pi value is what? Is 0. So therefore this term get vanishes. Similarly, if you apply the limits for this term also, this will be 0. So finally you are left out with an as what? You are left out with an equal to 1 by pi minus into minus plus, so 1 by n square is there, so take out that constant term n square outside. You're left out with cos n x limit x equal to 0 to pi, so which is equal to 1 over pi n square, apply upper limit, it is cos of n pi minus cos 0. Cos n pi is what? You know that cos n pi is what? Minus 1 power n, minus 1 power n minus cos 0 is what? Is 1. Is 1. So this is what? an. This is what? an. Now finally what we require to find out? We require to find out the constant term called, we require to find out the constant term bn. We shall find out that constant term bn. So Bn equal to 1 by pi integral minus pi to pi f of x sin n x dx. So now split the interval 1 by pi integral minus pi to 0 f of x sin n x dx plus integral 0 to pi f of x sin n x dx. Now substitute the values of f of x with respect to the intervals. So in the interval minus pi to 0, f of x is defined as minus pi sin nx dx plus in the interval 0 to pi, f of x is defined as x sin nx dx. So as you said in the previous constant an, so no need of applying Bernoulli's rule for the first term. We require to apply Bernoulli's rule for the second term since we have function of function. So I will name the algebraic term as u. I will name the trigonometric term as v. So 1 by pi times of minus pi is constant. Integral of sine is minus cos nx divided by n plus now apply Bernoulli's rule. X into integral of sine is what? Minus cos n x, derivative of nx is n, that is in the denominator, minus derivative of x is 1 into integral of minus cos is what? Minus into sine nx divided by n into n becomes n square, and derivative of 1 becomes 0. Therefore I will stop at this stage and apply the limit x runs from 0 to pi. So now see the term, which term will be 0? Sin n pi minus sin 0 will be 0. So we can strike it off the term sin term. So observe the left out term, and if you have any common term you can take out that term. Yes, we have a common term called n in the denominator for the both the term, so you can take out that outside. It becomes 1 by n pi, you are left out with minus into minus plus minus into minus. Here the limit will be, here for the first term the limit will be x equal to minus pi to 0. So pi cos n x limit x equal to minus pi to 0 plus into minus minus x cos n x limit x equal to 0 to pi. So 1 over n pi times of pi into cos 0, upper limit cos 0 minus cos of cos n of minus pi, when I give x equal to minus pi. Cos of minus theta is cos theta, so I can write that as cos n pi minus upper limit pi into cos n pi minus x into cos n pi, cos n 0. We are going to have, when we apply lower limit, 0 into cos 0, 0 into a real value is 0 itself, so we have 0 there. So which is equal to 1 by n pi into pi into cos 0 value is 1 minus cos n pi value is minus 1 power n minus of pi into minus 1 power n minus 0 is, So 1 a minus 0 will be a. So in that way I can write only pi times of minus 1 power n. So multiply this pi inside. Multiply this pi inside becomes 1 by n pi minus of minus pi into minus 1 power n minus pi into minus 1 power n. So it is of the form minus a minus a. So minus a is what? Minus a will be what? It is minus 2a. So minus 2a. So we can write that as what now? Left out with 1 by n pi into pi minus 2 pi into minus 1 power n. But we have a common term called pi. Take out that pi term outside. Pi by n pi, you are left out with 1 minus 2 times of minus 1 power n. So pi get cancelled, which is equal to 1 by n times of 1 minus 2 times of minus 1 power n. That is what? Bn. That is what? Bn. Therefore, equation star becomes what? F of x equal to a naught by 2. You can see what is a naught by 2. A naught by 2 is minus pi by 4, and substitute the value of a naught by 2. It is minus pi by 4 plus summation n equal to 1 to infinity. You can look at an value. An value is 1 by pi n square times of minus 1 power n minus 1. 1 by pi n square into minus 1 power n minus 1 power n minus 1 into cos n x plus summation n equal to 1 to infinity. Bn value is what? 1 by n 1 minus 2 times of minus 1 power n into sin n x. This is the required Fourier series for the given function f of x. So if you have any doubts, you can message me, and in the next class we will solve more problems on it. Okay.